All right, chapter 5, we completely switch gears on you. So another piece of statistics is probability, and that's what chapter 5 is all about. So we're starting off with the probability rules, setting the stage here in section 5.1. All right, so in true statistics format, we're starting off with some vocabulary. That's how we roll, right? This subject is lots of words. So we have to know what these words mean so that we can then use them. As you see, that's how we play this, right? You learn the vocabulary, you learn the symbols, and then you use them throughout. And that's what 5.1 is all about. We're starting that process here with probability. So the probability is a measure of the likelihood of a random phenomenon or change behavior occurring. We use this for long-term predictability. That's a D, predictability. So long-term predictability. So what we're saying is, what's the likelihood something's going to happen, and then we can predict what should happen next based on what we're currently looking at. That's a probability, the probability that something will happen next. All right, so we use that a lot in statistics, right? Okay, so here's a big thing, even if it's large numbers, so no pun intended. However, it is a huge deal in statistics, all right? So the law of large numbers, here's the key. As the number of repetitions increase, so as the number of repetitions increase, the proportion gets closer to the outcome. Moral of the story, do it a bunch. Do your experiment lots and lots of times. The more times you do it, the more accurate the data becomes. If you only look at something 3 times, that's not an indicator of what you can do to have long-term predictability. Do you see where we're going with this? So the law of large numbers says the more repetitions that you do, the more accurate your outcome will be. All right? That's the law of large numbers. That's a big deal. Okay. So here's a couple more key pieces of vocabulary that we need to use. So a sample space is capital S of a probability experiment is the collection of all possible outcomes. An event, which is capital E, is any collection of outcomes from a probability experiment. All right. So the sample space is all of them. So all the possibilities that are available, that's a sample space. An event is just a collection or of outcomes from the experiment. So it is an option that's available. So an event is just like a one piece of it. So I'm going to perform this event. I'm going to say, what do I want the probability of? And that's going to be my event, where the sample space is the possibilities that it can come from. Okay, so let's do an example of this, and then I think it'll make sense of what we're saying here. Oops, let me scoot it up. A probability experiment consists of rolling a single fair die. So what are my options, right? If I want to identify the outcomes, what could I do? I could roll a 1, right? What else could I roll? A 2. What else could I roll? A 3, etc., right? So you're seeing what's happening here. So, oops, that's not helpful. So event 1 is rolling a 1. Event 2 is rolling a 2. Do you see what's happening here? Event 3, event 4, event 5, event 6 is rolling a 6. Do you see what's going down? I'm not going to write all those. You get the concept, right? So if I want to list all those outcomes, those are all the different outcomes that it is that we're going to find. Now, the sample space is everything that's possible. So this is a set. So I'm going to do capital S equals, and then when you make a set, you put squiggly brackets around it. Now, I'm not so good at drawing squiggly brackets. That one's not bad that I just threw down right there, but I'm not always so awesome at it. So just do the best you can. But it does need the squiggly brackets because, again, in math, symbols make an impact. And a symbol for this makes an impact of how this all plays out, right? So I want to say a set, and this set in particular is the sample space. So then the squiggly brackets are used. So what are all my options? Because that's a sample space, is laying out all the options. Yeah, they are 1, 2, 3, 4, 5, 6, and then you finish off with that squiggly bracket. Okay, then I want to define E, which is an event, all right? So this event, again with the squiggly brackets, because it's setting a set. It's putting up a set. What are my even numbers? 2, 4, 6. So do you see the difference? The sample space is everything possible. The event is based on part of that sample space. That's the difference between the two. All right? Cool, right? I think so too. All right, so that's just laying out, making sure we have that as our vocabulary so that we can move forward with it. Now, hear this next. So tune in, right? If you tuned out or you're just kind of phoning it in, you better start paying attention, because here's the real deal, Holyfield. When you talk about probability, so this symbol, P of E, you're going to see this for the rest of the semester. We're going to talk about probability literally for the rest of the semester in different aspects. So this means, oops, I wanted to use this. The probability that whatever E is the event that occurs. So the probability that whatever I put in here is going to happen. This symbol is going to be important, so recognize it. The probability of any event, P of E, must be greater than or equal to 0 and less than or equal to 1. That is, this is happening now. This is what you need to know from this. Probability, learn how to spell. That's step 1, right? Probability is a decimal or fraction. Most of the time we write it as a decimal, and the decimal has to be between 0 and 1, inclusive. This or equal to symbol that's underneath the 0 and the 1, that means inclusive. Does it say fraction in here? Pardon me. It does say fraction. Does it say percent? No. Ooh, do you hear that? I'm going to say it again for the cheap seats. Does it say percent in here? No. This is a probability, is a decimal typically between 0 and 1. It can also be as a fraction because fraction and decimals are synonymous, right? But the key is it has to be less than or equal to 1. 1 is the most. And if I were to call this a percent, that would be 100%, all of it. This is 0, none of it. You can't have something that's a negative probability because you're saying, based on a sample space, what is my event? How many am my event? Well, you can't have a negative situation there. It has to be between 0 and 1. There are always 2 scenarios that you have to deal with, 2 rules that you have to deal with. Rule 1, it has to be between 0 and 1 inclusive. Rule 2, add it up to be 1. That's the deal. Add this up. The sum of the probabilities must equal 1. That means everything is accounted for. That's what that means. So you always have two rules. If you want to say, is this a probability? You always have 2 rules. And those 2 rules tell me that it's between 0 and 1 inclusive, and the sum is 1. All right, have I beaten that drum enough? Have you got that? All right. Let's try to switch pages here. Let's put it into effect. Here it is. The color of plain M&M milk chocolate candy can be brown, yellow, red, blue, orange, or green. So suppose a candy is randomly selected from a bag and table 1 shows each color and the probability of drawing that color. That's what we're looking at right here. To verify that this is a probability model, you must show that rules 1 and 2 are satisfied. Anytime it asks, is this a probability model? It's not really ever going to say, you must show rules 1 and 2. It's just going to say, verify this is a probability model. And you automatically know you have to verify these two aspects. Aspect number 1, that the probability are all between 0 and 1. And that's a good visual representation. Is there anything that is less than, is the negative or over 1? No. So we're good. 0's legit. You could have a 0 in there. You could have a 1 in there, right? But all of these are between 0 and 1. And notice, what are they? They're decimals. What did we say it would be? A decimal, right? So yes, this is good. This criteria is met. Yes. Ooh, that moved around, so it got a little wonky donkey on me, didn't it? That's supposed to be an arrow, but it doesn't really look like it. Yes. All probabilities are between 0 and 1 inclusive. Now, the inclusive is the key because people forget you can have 0 and you can have 1. Now, this one doesn't have that scenario, but you could, right? And then what was the second rule that we had? Yep, the sum of all the probabilities can equal 1. Remember that sigma means sum. We've already talked about that before. So we're going to use that same symbol. Do they? I don't know. Add them up. I'm going to put the double line because the double line means total. Plug that into your calculator. Add all those up. What do you get? Yeah, if you haven't already, I'm just going to tell you, you get 1. So, yes, they add up to 1. And that is the criteria that has to be met. All right? Okay, so anytime it says verify a probability model, those two things are what you need to do, is the probabilities between 0 and 1 inclusive and that they add up to 1. All right, so we talked about it being a 0 or being a 1. Let's actually give those names. An event it's called impossible. It's impossible if it's 0, because if you have a probability of 0, there is no chance that's happening. And it's given a word, and the word is impossible. All right? An event is certain if the probability is 1. That means it's 100%. There is nothing else that can happen. Nothing else is going on. You are completely guaranteed that's the maximum you can have. If this had been a whole bag of blue M&Ms and this probability was a 1 here, all of these would be 0. You are certain, if you have a bag of blue M&Ms, to pull a bag of blue M&Ms. It would be impossible to pull a brown M&M from something that's all blue. See what's going down there? Nice. Okay. Then you have an unusual event. Is an event that has a low probability of occurring. And specifically, this has a low probability of occurring, but specifically, it is less than 0.05. So in order for it to be unusual, you can't just say, oh, that's my opinion. No, there's no opinions. This is math. So you're not looking at an opinion here, the low probability, but specifically a low probability that's less than 0.05. That's the key there. All right, good. We're getting it set up. That's a good thing.